All right, so we're going to start now. So, you might remember, a few weeks ago we had a very difficult class. We spent about an hour talking about residuals. Remember that class? That was a very heavy class. I reckon today's class is a close second to that one. All right, so this one's going to be challenging as well. You'll see why, because there's a lot of steps to follow. So I'm going to go through it. When we get to the end, I'm sure you'll have questions and we can break it down at that point. So the first thing I want you to do is get your CAS calculators, and I want you to key in just these two columns of data. Just those two columns. Okay? Alright, so that might take a couple of minutes to do. So you might need to do this a few times during the exam. Yeah, yep. So just giving you a heads up, you'll also do this several times during the SAC as well. Sorry. Alright. So you look at that. I'll key it in on my calc now. So as you can see, it actually does take a while to get your data into the CAS. You want to be able to do it without looking at the calculator if you can. Okay, so I'm done.
Which one's even? Where you go age is the EV?
Excellent question. So I haven't told you yet. So just get the data in.
No, I'm assuming you gender right now.
So just hands up if you've got the data in.
Oh, I was wrong. Yeah.
All right, so I'll give you 30 more seconds if you're still going. I would like you to just open up page 249. It's got this graph on there in a textbook. Yeah, so that's where I've gotten this data from. $249. So as you get that open, I've included the scatter plot from the textbook here, a little screenshot. So just have a look at that scatter plot either in your book where it's going to be bigger and easier to see, or on the screen. So Jason, I'm going to ask you, since you've got it open, do you think a linear model is a good fit here to the data?
Yeah, no, I don't know actually.
Please explain. It's curved, yeah?
Yeah, it's no linear.
Okay, who was away last Friday? Hands up. Okay, so if you were away last Friday, we introduced this idea that we can apply a transformation to one of the variables to model data that is curved. Okay, so I might replace x with x squared or log x, and today 1 on x, or similarly with y, and then we'll get a straight line, and then we can do our normal linear regression analysis. So the question is, which I didn't answer last lesson, which transformation should we pick? There's actually 6 possibilities for us. So So there are 6 possible transformations to choose from. You will only apply a transformation to one variable. On Friday, we covered those 4, and I've drawn a box around. So today we're just going to introduce one more, but there's still a question of how do we know which one to pick? Because on Friday, I just gave you the transformation, or the textbook gave you the transformation. Is there a way that I could work out which transformation to apply here? I don't expect you to know the answer to this question, by the way. But just to get you thinking. So, if you've got the textbook open, please turn back now to page 239. And there's a very helpful diagram there that will allow you to choose an appropriate transformation.
Oh, so we're going to go with log y, 1 of y, or x squared.
So, Kaylin and Tim, have you found the diagram? Do you have a textbook? Well, get that.
One over y, it's a log of y.
Alright, so we found the diagram? Alright, so it looks like this. This is the diagram in the textbook. Now, I've shown the scatter plot here again. So I'm gonna give you some help here. The curvature is kind of like this. Okay, so have a look at the orange line. Have a look at the circle. Which part of the circle most resembles that orange curve there?
Top left.
This one?
No. That was it.
This
Bottom right. Just messing.
bottom right. This one, okay?
We were testing you there.
Okay. All right. So, you don't need to know where this comes from. To be honest, if you Google this, nothing's going to come up. You'll just see people copying the Cambridge test. This is not a thing. So, this is just so the Cambridge authors have come up with this diagram to help you choose a transformation. So what they're saying is, look at the curvature. If it's curving upwards like this, try these 3 transformations. If it's curving upwards like this, but it's getting less steep over time, try these 3 transformations. Okay? So this needs to be in your bound reference, because I don't expect you to remember this, and I certainly don't. But remember the question that I started off with. How do I know which transformations I should choose? You want to use this diagram. Okay? And because you probably won't remember this diagram, it needs to be in your notes when you do this and when you go into your exam as well. Okay? So are we all right so far? So we've got data in our calculator. We've figured out which transformations we want to try. Now we're going to test all 3.
We can just do one if you like.
Yeah, so what I think I'll do is I'll split up the work. So maybe one person will do one transformation, next person will do the other one. All right, let's see if this works this time. Okay, can you see the calculator?
Yes.
Okay. All right, so if you were here last Friday, I'd like you to remind me. I've got the raw data, and And in a moment, we are going to try x squared, log y, and 1 of y. The circular transformations have told us that we should try those three transformations. I've got x and y here on the caps. How do I apply the transformation?
Make it value.
Well, which one's x and which one's y? Is our first question.
X is length.
Yeah, in the scatter plot, in the textbook, x is length.
Okay, so length, so in C we put length squared.
Okay. So I'll name it LENGTHSQ for length squared.
And then if I want underneath you press enter, and then you do length with the actual square.
Yeah, so you don't press enter. If you press enter, oh, it does work. Okay, thank you. Press enter, and now you type in the formula. So I'm going to say length, which is the variable we want to transform, and now I'm going to square it. So press the square button down here. Yep. Alright, and watch what happens. Especially if you weren't here on Friday, watch as the whole column gets filled in, like so. Okay, so you must not square each value individually. Use the spreadsheet, because that'll waste way too much time. Alright, we've got x squared. I'll do length as well with the log. So this time it'll be equals log 10 length. So make sure you're able to get the log 10 transformation of length. Base 10. Just log of.
Oh, I didn't get it.
Sorry. It's log of y. So we shouldn't be taking the log of length, we should be taking the log of h. Sorry. Okay, equals log 10 h. So our explanatory variable is length, and our response variable is age. So previously, I took the log of length, not the log of age. Yeah, and I'd be in the wrong part of the circle. Hmm? Okay. Yeah. Okay. If you finish, try to do this one. 1 divided by h. Create a new column for 1 divided by h.
Oh, did I do it? I did it. Hold on. Did I? Yeah, I accidentally said added that. I will be like
Okay, so I'm going to show you the last one now. We haven't talked about this. This is called the square transformation, the first one. Second one's called the log transformation. The last one is called the reciprocal transformation. Reciprocal is just a fancy word for flipping the fraction upside down. Or taking one over the number.
Let's take two steps back.
Okay, so I'm going to call this a direct for the reciprocal. Okay, equals 1 divided by age. Press enter.
Oh, why are they all sixes? Yeah.
Because those three numbers are the same. So if you take 1 divided by those three numbers, you'll get the same results. Huh?
Just that line.
Yes? Here? This one? Yeah, equals 1 divided by age. Here, age is my y variable, and I already named it previously in another column. So I'm referencing that. The one at the top is just a name, which we will use later. Okay, we haven't even made the graphs yet. We haven't looked at the residual plots. We haven't calculated r squared yet. Can you see how much work is involved here? Yeah. We've got 3 graphs going on here. All right, but this is, in some ways, we've done a lot of the hard work already. We've got the data into the calculator, and we've applied the transformation. Okay, so this is what we've got at the moment. Before last Friday, we only had one model. Jason, listening in. Before last Friday, we only had one way to model data, and that was with a straight line. Y equals A plus BX. Today, we now have 3 transformations to choose from. Those are the square transformation, the log transformation, and the reciprocal transformation. Notice I put the stuff in orange to indicate which variable has received the transformation. So either y or x, but not both. You will only apply a transformation to one variable in this class, never two. So the next step for us is to actually calculate the values of a and b, and to put the equation in words, because that's the way that VCAR tends to present it on the exam. So x is length. So I think it's a good question. Most of the time, they actually give you the words, and you fill in the numbers. Yeah. But you've got to understand that what the words are referring to, which is the variable. So I do think it's possible they could ask you to put the words in, though. I don't see why not. Like they could give you one word, and you'd fill in the other one, something like that. Okay.
Like yeah, so if we were working out like A and B ourselves, we just would it be alright if we just wrote Y, or would we have to write?
So I think if they ask you for a worded equation, which is what I will do on the stack, then you need to give me words. Okay. So if in doubt, just supply it in words, and I think you'll be safe. Okay. So I'll do the first one for you. No. Bad start already. And this is really slow because of this. But I need that. Rats. Okay, so can you see, guys? I've just replaced y and x with age and length. And now I'm going to chuck some numbers in as well. You know how to find the numbers here.
Yeah.
How do we do that?
You put it in a graph.
And then put the regression lines.
Okay.
That's one.
So, great. So I'm going to, rather than us doing all four, how about we split off? So one person with a calculator can do the first one, another person can do the second one, the third one, the fourth one.
It's a fourth one.
Yeah,
The fourth one's just.
so the first one is just no transformation. Okay. So we're after some numbers A and B here, but they're going to be different for every single model. So who wants to do the first one? First one's the easiest one.
Taylor does.
Okay, so Taylor will do the first one. Who wants to do the second one?
Which one's that one?
That one's the x squared. X
I've
squared,
already done
then
that. I'll do
log
that
y.
one. I'll do that one.
So Tom, are you doing x squared or the log?
X squared.
So that's this one.
Well, I'll do that one then.
Okay, so x squared's the last one on the
I'll
board.
do the last one.
So Tom's going to do the last one. Taylor's going to do the first one. Okay, Jacob's going to do the second one, and someone's going to do the third one. Hang on.
Thanks, Harry.
Who else could calculate?
Let's see, calculator there, calculator there, calculator there,
I
calculator
was
there.
still trying to figure out how to do it in general.
Okay.
No, what's the third one?
Sorry, what was
There
that?
was 2 columns on the test that wasn't working right.
Okay, so I'll fix that.
I think I have it maybe.
Okay. All right. Please go forth, and if you have time, try to work out the third one, which is the new one for today. 1 divided by h. So you'll need to use the names. Actually, there's a big risk that I send you off not knowing what you need to do. So let me remind you. Here's how you create the scatter plot. You're in a spreadsheet. Control I. Control I. Option number 5, data and statistics. You get the scatter plot. And now you need to be very careful which one you choose. So let's say I wanted to do the third one, which was 1 on y versus x. So x was length, and y was age, but I want 1 on y. And that's why I named it age reciprocal. It was important that we gave our variables useful names so that we could recognize it at this step here. Okay? All right, so I've already now done the third one. So menu, analyze, regression. Well, we'll investigate that, okay? Show linear, and you'll get an equation. Okay. Now, who needs help? Shelley, I'll help you out. Jordan will help you out as well. Okay. So this is a formula. Equals log of whatever variable.
And how would I do that?
Simple. Equals.
What are you up to in work? So how many classes assignments? A good four. I'm gonna go and stop talking. I'm gonna ask you to stand up. Just speak down. Yeah.
That was actually like 4 years.
So my calculator does. I found it most of the calculators do.
Yeah.
I didn't really grasp if I know what you were talking about.
So I reckon we've got the raw data here. There's nothing goes in here because you're not applying the transformation. Now, what do you want to transform? So I reckon they want to go this transformation.
It's either that
Hang on.
or
What are you doing? You can ask next time, yeah? Okay, which one's yours? GDP? So let's do that. Let's call this GDP long. This is just a name. And now you type the formula there.
Thank you. And do I just type in the wrong?
watch me. I've got them wrong.
Yeah, sure. No, use control 10x. Okay, sorry for the wait, guys. So I'm going to show you how to write this. So instead of age, when I apply the log transformation, I'm going to write log age.
Hey, that's what I wrote.
Yeah? Great. Instead of 1 on y, I'm going to write 1 on age.
That's what I wrote.
Okay, and instead of length, did you write this too, Jason?
No, actually, I'm not doing it yet. I'm just kind of writing.
Length squared.
Is that me? Mine? Are you doing this one? Oh yeah, length squared. Gotcha.
Yeah, that one's
Age
you.
on the other side. Just age.
Very good.
Would you like the numbers
Sure.
for the last one?
Yeah.
Alright then. Let's take a guess. What do we got here? Alright, we got
So just round it to 1 decimal place,
one
please.
decimal place. Alright then. Negative 10.3.
Yep.
Plus 3.5.
Yep. Okay. Just wait, Jason. Let me put my one in. 2.6. And they've actually given a minus here. And this is the problem with using this at the same time as this. It just lags so hard. Okay, Jason, let's hear your one. Yep. Okay. And Taylor, you did the first one?
Negative 25.6.
Yep.
plus 14.6.
14.6.
14.6.
Okay.
All right. We've now got 4 models. So I know a lot has happened today. So let me recap. We started off, because I don't want you to lose sight of the big picture. We started off with some nonlinear data. Okay? Started off with some nonlinear data, and then I said, okay, we can make find one of these transformations. The question is, which one should we choose? Answer, use this diagram. Okay? And the diagram directed us to these 3 transformations. So that's why we chose these 3 ones. So notice that one of them applies the transformation to x, the other 2 are applied to y. Okay, it won't be that case if you go somewhere else. Okay? Once we found which variables we wanted to transform, we then had to apply the transformation in the cast using the spreadsheet. Then we did our linear regression and found our equation. And after all of that, now we want to ask the question, is there one that's sort of better than the others?
Yes.
Okay, which one should I pick? Because right now, I've just got 4 equations and I don't know which one to pick. Should I choose all of them? Should I choose only one of them?
Well, the bottom one.
You want to pick the bottom one? Why, Tom?
Just because it looks easier.
It does look easier. You only squaring x, you got no logs. Logs were upsetting.
Yeah.
And reciprocal, who uses that word anyway, right?
So was I right?
No. Unfortunately not.
Why didn't you make it hard?
No, so it turns out it's the middle 2 that are good here. But I haven't told you how to know that yet. So this should also go in your bound reference if you're writing in that. So there are 2 things you want to look at before deciding. There are 2 things you want to look at before deciding that your transformed model is better than your linear model. The first thing you want to look at is r squared, the coefficient of determination. There's like a 5-second delay there. And the residual plot. So, if your model is better, so I'll circle the word better here, then one of the things that you should observe happening is that your r squared value should go up. Yeah. We'll talk about that. The other thing you should look for is whether it's similar or looks more random. So no clear pattern. So remember, this is about 2 weeks ago now, I think. We said that if we fit a model to some data, we want to look at the residual plot. And if the plot looks random, that is to say that there's no clear pattern, then that's a good sign. So you want that ideally to happen after you apply your model here. Okay? But that won't always happen. It might look similar, it might look a little bit more random, but it might not look completely random. That's fine. All right, you got that down? Okay, who did not get r squared on their scatter plot?
No.
Okay, so if that happens, if I go back to the calculator, unfortunately, I don't exactly know why my cast gives me r squared and yours doesn't.
I figured it out.
You figured it out.
Yeah.
Would you like to share?
Sure. So if you go to like menu and you go all the way down to settings, right? And then you go and you just like tick diagnostics and then it just pops up.
Ooh, okay. Why don't you try that?
What is it?
So Karen was saying menu, settings, and then tick that box which says diagnostics. Thanks, Kaylin. Let's see if this works. So did it come up?
Yeah.
Oh, excellent. Okay, the other way to do it is to get it in the spreadsheet, the way we get all our other summary statistics. Okay, so now that this has worked, Taylor, can you tell me what the R squared value is on yours? Just 3 will be enough.
So 0.770.
770. Okay. Jason. Jason. Have you got your?
I do not have settings.
You don't.
Hashtag, what the frick?
Okay,
I've
so
got 5 options when I open menu. Hashtag, help me see happy.
okay. All right, we'll come back to you. All right. So my one had 0.855, and Tom.
Just slap me.
Tom, do you have the R squared value for yours?
775.
Yep. Any luck, Jason, with your calculator?
What the heck, man? What the actual frick?
All right. I'll give you a moment there, Louis, to try it. I've also done the calculation somewhere else. So I think the log 1 is 0.886.
Now that I can't do that, what's the equation to find R again?
There isn't one in this course for you. The only way to get R, if you can't get it in the graph, is to do it in the spreadsheet. Okay? So stat calculations, linear regression, A plus BX, so just do it that way. Okay?
Please do not change that. If you can make this a business.
Okay. Any luck?
What have you done? You're retarded.
Yeah, let's do it.
Why use those? I listen to it.
Sorry.
No, it's just figured out how to change the language back from Chinese.
Did you put it into Chinese? Why did you put it into Chinese?
I didn't shit you.
I didn't.
What's that?
I didn't.
It was this kid. Yeah, it was this kid. See, he's got China.
Orange and yellow. Yeah, that's the thing.
No, I didn't have to get his cancelled in case it gets to
Oh, no, use it. No, no.
Okay, sorry, year 12s. Could I get everyone sitting down? So, Jason, return to your seat.
What are the
Go, return.
what are those pins called?
Safety pin.
That.
That's really.
And I saw him walking around and you holding it.
I told him that I hoped to.
Oh.
I told him that I hope he gets infected, and he got really mad at me.
Well, he's just retarded.
At this point.
Okay, for this last part,
Yeah, so Jason, we can investigate your calculator. All right, so if I could get everyone looking at the board now, you see how long this took to generate 3 models and to analyze one? This is why it's unlikely it will be on the exam, because it just takes too long to test all 3 models. But I will do a cut down version of this on the SEC. So I won't ask you to check all 3 models. I'll ask you to check one model and comment on it. Okay? Did you have a question? Okay. So yes, this is on the SAC. This is probably the hardest question on the SAC, or the second hardest one. So, before we were saying if our nonlinear model has done better, we should look at whether r squared has gone up. So have a look here. This was our original r squared value. So is the x squared transformation much of an improvement here? Not really. We might still want to look at the residual plot though. But these two look promising. But we still want to check the residual plot as well. So do you know how to get that on your scatter plot?
I don't quite remember. So if you want to.
Yes.
Yep.
Guys, it is. I'll tell you.
Oh, you go menu.
Menu.
Yeah.
Residual.
Very good.
Yeah.
So analyze residuals. Show residual plot. You can only get residuals after you fitted the line. Okay? And it will show up underneath. This thing? Yep. So just this once, because I've done this in Python somewhere else, I'll show you what the residual plots look like. So this is with no transformation. How would you describe this residual plot? Is there a pattern here? No. Not really. So that's a good sign. Okay. So if you want, we can write no clear pattern. So just think about this, right? The textbook told you that it's clearly nonlinear, but the residual plot doesn't really suggest that. So it's a little bit subjective. But can you see that after we applied the transformation, we did have more explanatory power here. We're explaining more of the y variable. Yeah? Okay. All right, so x squared. So this was the one that Tom did. So compare these two plots, the residual plots.
Yeah. Not much difference, is there?
Not much difference at all.
Ah, you got me. So is that good or bad?
It doesn't really matter because you don't want a clear pattern in your residual plot. So if you gave me this model, I'd be like, well, it's pretty much the same as the first one, so I wouldn't really care. Right?
But log 10, is that good? Because it went up.
So the r squared value suggests that it's better, but we have to check the residual plot.
Really?
Yes, you want to check both. Okay?
Will we?
Okay, this is log y. Does that have a pattern?
No.
Yes. It's right.
If you think there's a pattern, you need to show me what it is.
Is it a curve?
Yes.
Do you think there's a curve?
No, not really.
Yes.
It's subjective, isn't it?
Yeah.
Right?
Well,
So
you could have a little bell curve.
what, this? A bell curve?
No, the other way. What's it? Is it called different?
What, this?
Yeah.
You think there's this happening?
Oh,
Is that
for
a corrupt?
sure.
No,
You can clearly see it.
Well, I mean, if you felt like it.
Well, it's like an
Looks
N.
random.
Yeah.
If you wanted there to be a curve there.
Yeah, well, it doesn't look random
Yeah.
to me.
So here's the thing. So on the exam, it'll always be very, very obvious when there's no clear pattern. But when you're dealing with real data, this is what happens. Okay? Life isn't as pretty or as simple as the textbook might lead you to believe. Okay? So if you argue that this is random, I'm fine with that. But I'm just going to say it's subjective. You could go either way here. As long as you can justify what you're saying, I'm happy.
Sorry, in other words, I'm
Everyone's right, as long as you can justify. Okay.
pattern there.
So here, I think the pattern's pretty obvious here.
Oh.
Okay? Here, there's definitely a curve happening.
Yeah,
So even though, please notice, even though r squared went up, our residual plot got worse. So I would not want to use this model.
so x squared is the one to use.
Or log y. Yeah. Either one's fine. Okay?
Okay, well that's fine.
So this one has a clear pattern. Which means you don't want to use it. Okay.
Oh no.
So we've done a lot. Is the period over yet?
Yes.
We have.
The single period.
We have like 40 seconds.
Okay, alright, so it's not too bad. Alright, so here's a summary, guys. Let me summarize the whole
20
lesson.
seconds.
We started off with numerical data on a scatter plot. Okay, so this picture here. Alright, and that data may or may not be curved, but we always start by fitting a linear model. Then you check the residual plot. If it's random, you're done. You don't need to apply a transformation. However, if there's a clear pattern, then you want to check the circular transformations, which was this thing here. You look at the curvature to decide which of these transformations you might think of applying. Yeah, I'm almost done. Okay? Check your transformations, apply them on the CAS. Then you need to do what we did just now in that table. Check R squared and check the residual plots. And then choose a model. Okay. A break is in order. So, are there any burning questions?
No.
Unanswered questions that you won't be able to go to bed without having them answered? Okay. So I'm going to say you may have a break for a few minutes. After that, so I'll just show you what's happening. So we've just covered 4C and 4D, which is the end of chapter 4. This is what's coming up. SATs in 3 weeks. So it's a busy few weeks ahead.
We've got a quiz tomorrow?
Yes, quiz every fortnight.
That's right.
I'm so
I've got tutorials.
excited.
I've got classes.
All right, so if you need to go to the bathroom and etc., go for it. Come back in the next 5 minutes.
10 minutes.
5 minutes.
20.
5.
Thanks for coming.